3 under square root times 9 under square root times 27 under square root under square root under square root. So this is called nested radical equal to 81 to the power 3x. We have to find the value of x. Now when a is under square root, it means a is raised to the power of 1 upon 2. And when a is under square root, again under square root, it means a is raised to the power 1 upon 2, then again raised to the power of 1 upon 2, and it means a is raised to the power of 1 upon 4, like this. So using this property we can solve. Also, when a is under square root, to remove it, we square it. When we square it, it gets removed. So let's use the two methods. First method, let's square both the sides. So squaring both the sides, 3, 9 under square root, then 27 under square root. We square it, and to balance the equation, we square the right hand side also. This square removes the square root, so it is now 3 times 9 under square root, then times 27 under square root is equal to 81 raised to the power 3 times 2x is equal to 6x. Again squaring both the sides. So we have 3 then times square root 9 times square root 27 under square root. We square it is equal to 81 to the power 6x, then whole square. Now when a times b is raised to the power of m, it means a is raised to the power of m, then times b is raised to the power of m. Therefore this square is over 3, so 3 to the power 2, then over 9 times square root of 27 under square root, like this, is equal to 81 raised to the power of 12x, or 3 square. This square root removes the square, so it is times 9, and then times 27 under square root is equal to 81 raised to the power of 12x. Again we square both the sides, so 3 square times 9 under 27 square root whole square is equal to 81 raised to the power of 12x whole square. Now we have 3 raised to the power 2 times 2 is 4, 9 raised to the power 2, and this square root, remove this square, is times 27 is equal to 81 raised to the power of 24x. Now we have 3 to the power 4, 9 we can write it as 3 square, then raised to the power of 2, and 27 as 3 raised to the power 3. This side also 81 we can write it as 3 raised to the power 4, then whole raised to the power 24x. Now using the identity a raised to the power m times a raised to the power n is equal to a raised to the power m plus n. We can add the exponents here. So 3 raised to the power 4 plus 4 plus 3 is equal to 3 raised to the power 96x, or 3 raised to the power 11 is equal to 3 raised to the power 96x. Again, when a raised to the power m is equal to a raised to the power n, and a is not equal to 0 or 1, then m is equal to n. So that means 96x is equal to 11, or x is equal to 11 upon 96. This is our answer. Let's verify this answer. So 3, then square root of 9 times square root of 27. Square root of 27 is 3 times square root of 3. Then 9 times 9 is equal to 81 raised to the power 3 times 11 upon 96. We have to check whether LHS is equal to RHS, or it is 3 times 3, 11 upon 32, or 3 under square root, then times 27 under square root, and this we can write 3 under square root is equal to 81 raised to the power 11 upon 32. Again 3, 27 is 3 times square root of 3, then square root of 3 under square root of 3. So 3 times 3 is 9. So 9 under square root, then square root of 3 under square root, then 3 under square roots of square root under square root is equal to 81 raised to the power of 11 upon 32. We have to check. Now square root of 9 is 3. 3 raised to the power, it is 3 raised to the power of 1 upon 2 times 1 upon 2. then 3 raised to the power of 1 upon 2 times 1 upon 2 times 1 upon 2. Now add the exponents here. 1 plus 1 upon 4 plus 1 upon 8. 3 raised to the power of 8 is the common LCD. So 8 plus 2 plus 1. 81 we can write 3 raised to the power 4. Then times. Then whole raised to the power of 11 upon 32. So it is 3 raised to the power 11 upon 8. And this side we have 3 raised to the power of 4 times 11 upon 32. 4 times 8 is 32. So 3 raised to the power 11 upon 8 is equal to 3 raised to the power of 11 upon 8. LHS is equal to RHS. Our answer is verified. Like and subscribe. Thanks for watching.